Welcome back. We're just getting started. All right, here we go. The definitions of trig functions in terms of the unit circle. We got that test intended, and also there's no calculator on that test, so we want to kind of keep that in mind today. If theta is a real number and point xy is a point on the unit circle, that's a whole lot of complicated stuff to tell me. Just use x's and y's. Then sine theta, is that x or y? Y. And cosine theta, is that x or y? X. And tangent theta, is that x or y? A little bit of both. Y over x. And it's been a while since we learned of our three other buddies. Cosecant matches up with sine, and it is 1 over y. It's just the upside down of sine. Whatever you get, you flip it upside down. And then the secant is just the upside down of cosine. Now, it might have been a while. Remember that cosine does not match with cosecant. Those are not a match, which it would be nice if the cos match together, but they don't. It's sine and cosecant, cosine and secant. So that's something that we learned, and you guys were good about that, but I just want to throw it back by you. Cotangent theta is the upside down of tangent. That one's nice and easy to remember, and that one would be x divided by y. This is stuff we've already learned before, and so not adding any new information, just asking a different type of question. If you look at those bottom 6 questions, they're not asking you about the sine of 30 or the sine of pi 6 anymore. They might ask you about the secant or the cotangent or the cosecant. And so basically, same answer, just got to flip it upside down. So let's see how some of those numbers work. A little bit of a hint, your warm-up has a lot to do with it. So here we go. Plus. Up first is the secant of pi over 6. All right, if we're thinking the secant of pi over 6, we want to be thinking about our unit circle. Pi over 6 is in that first quadrant. Some other things I like to think about. Secant, that is not sine, cosine, or tangent. Who's buddies with secant? Cosine. So I'm thinking cosine upside down. I'm also going to think quadrant 1 is cosine positive or negative in quadrant 1? Positive. So I know for a fact that my answer is going to be a positive number, because cosine is positive, and when I flip a number upside down, that doesn't change its sign. It's going to stay the same. So, all right, cool. Now I just need to go on my unit circle or use my memory here. Pi over 6 is 30, and a lot of us remember that the square root 3 comes first for 30. Cosine is the x position, and that's the answer, but we got to flip it upside down. And so our final answer here, it's what we did on our warm-up. It's one of those numbers. Our final answer here would be, flip it upside down, 2 over square root 3, write it better, 2 square root 3 over 3. Again, I kind of think 2 thoughts. First of all, secant matches with cosine. It's just upside down. And my second thought is, which quadrant am I in? Let me just grab the sine, okay? I always like to just do the sine as like its own separate thing and just get it done with and put that there and then not have to worry about it anymore. Any questions about this one? I don't imagine we have too many questions. Again, if I just kind of locked the door and said no lunch till you get the right answers, I think we would get the right answers even without me. So cosecant, I don't need to write theta, I need to write negative 2 pi fourths. I have 2 thoughts. Which one does cosecant match with? Sine, but upside down. And my other thought is, which quadrant are we in? Where are we? Well, 2 over 4 is kind of, yeah, right? It's not a simplified fraction. So like, can we just simplify that fraction, please? Pi halves. So cosecant would be negative pi halves. I like that. Up to you, you can leave it as negative pi halves, or you can do your coterminal angles to spin it all the way back around to its standard position. Let's just, you know, do a little extra since it's notes. Maybe we don't do this for the classwork, but we add 2 pi, which would be 4 over 2, and we get 3 pi halves. So we're really trying to do the cosecant of 3 pi halves. And on my unit circle, 3 pi halves is in this position. Now that's a quadrantal, but the quadrantals are nice, okay? Because the quadrantals are zeros and ones. We just take either a 0 or 1 and we flip it upside down. This quadrantal would be 0, negative 1. And so what is my final answer going to be for this question? Negative 1, okay? I'm noticing, I guess I should write quadrantal in here. That's my thought. But sine is its buddy, sine is the y value, it's negative 1. Flip the negative 1 upside down. Maybe you write it like this. Flip it upside down, it's still negative 1, right? Negative 1 upside down, still negative 1. That question a little bit ugly. I don't really like the 2 over 4, ew, simplify that. And of course it's a negative, so I just went ahead and did coterminal. Let's see if we can speed it up a little bit. Cotangent of 330 degrees. Okay, 330 is nice. I don't need to simplify that. I don't need to do coterminal. I'm going to think about who's the buddy and what quadrant are we in. Who's the buddy of cotangent? Tangent. It's got to be upside down though. And then 330, which quadrant are we in? 4. Quadrant 4. Okay, we're in a quadrant this time. Is tangent positive or negative in that 4th quadrant? Tangent is negative. Okay, remember a smart trig class. So the 4th quadrant is C class or cosine positive. A smart trig tangent is positive in that 3rd quadrant. So this is a negative. So my answer is going to be negative something. Okay. Then I want to think about my 330. And my 330 is over here. My 330 has a reference angle of 30. It's only 30 degrees until it gets to 360. It has a positive x and a negative y value. Square root 3, 1. Now the tangent would be y over x. The tangent would be 1 over square root 3. The cotangent, flip it upside down, square root 3 over 1. Final answer, negative square root of 3. So I'm using my knowledge that cotangent matches with tangent. Okay, good. I just need to flip it upside down. I'm also thinking about I'm in quadrant 4 where tangent is negative. Boom. Then I go to my unit circle and I either grab the x or the y. Tangent needs y divided by x, so I grabbed 3 and square root, or sorry, 1 and square root 3. But then I need to flip it upside down, square root 3 over 1. There's my final answer. Let's keep going. Cosecant of negative 45. Negative 45. Do we just want to leave it negative or we want to do coterminal? Sure, coterminal. Negative 45 plus 360 is 315. Okay, nice. So this is basically the cosecant of 315. Cosecant is whose friend? Sine. And 315, which quadrant are we in? 4. Quadrant 4. A smart trig class. Cosine is positive in the 4th quadrant. Cosecant, negative. Because when I'm doing the positives and negatives, I'm thinking mostly about the sine, not the cosecant. Because I have memorized a smart trig class for all all sine, tangent, and cosine. Okay, 315. This is one of our 45s. We love the 45s because they have the exact same thing. Square root 2 over 2, square root 2 over 2. Sine tells me to grab the y value. Square root 2 over 2. And of course, I already know it's going to be a negative number because this is negative in the fourth quadrant. But what did I do wrong? Exactly. She's got it over there. I did all this work and I found what I needed to find, but I never flipped it over. Okay? This is a valid sine of 315, but it's not a valid cosecant. Okay? I skipped this step where I found this number, and then I need to flip it upside down. 2 over square root 2, ew, rewrite it, then simplify it, because next up I'm going to get 2 square root 2 over 2, and then the 2's are going to, that's what we did on the warm-up. Final answer, negative square root 2. That is the cosecant. So it's a very common thing to see students articulate, okay, this matches up with this, okay, it's going to be positive, okay, here's my number. But the whole thing we're learning today is now that you got that number, flip it upside down. 2 questions left. Cotangent of 5 pi thirds. Again, I'm going to try to speed it up a little bit. Cotangent is buddies with tangent. Just got to be upside down. Cotangent 5 pi thirds is in quadrant 4, where cosine is positive, but tangent is negative. So my answer is going to be negative something. 5 pi thirds is going to be down here. Everything's divided by 2. It has a negative y value. This one is 1 and then square root 3. Tangent normally is to grab the y divided by the x, square root 3 over 1, but cotangent is the other way around. 1 over square root 3. And the best way to write that is square root 3 over 3. Now this is me writing everything down, writing down way more than you have to write down. And even then, it only takes about 30 seconds to do a question like this. Very last one. Secant of 7 pi halves. What quadrant is this in? We should know right away. It's quadrantal. And how do we know that so fast? It's divided by 2, right? Divided by 2s are always quadrantals. They're either going to be at that 90 measure or that 270 measure. So secant, I'm thinking secant is buddy with cosine. I'm thinking, well, this one is going to be quadrantal. So second time I made that cloud a little too small. I'm thinking 7 pi halves is a little crazy. You guys seem to like the coterminal, at least the people who speak to me. They're my favorite anyways. 3 pi halves, and 3 pi halves is down here. I think we already did 3 pi halves. Yeah, when we did number 2, I guess, we did 3 pi halves. But we're back here, which is cosine, which is 0. So what is the final answer for this question? Undefined. Undefined. Because the answer for cosine of 3 pi halves is 0, and we're doing the upside down, which means that 0 gets put onto the bottom. You're not allowed to have 0 on the bottom. Final answer, undefined. I said it a couple times. There's not really anything new today, okay? It's just you see these different trig functions, you gotta flip them upside down. When you flip it upside down, you do get a bit of a wider variety of numbers, right? We saw things like square root 3 over 3. We saw things like 2 square root 3 over 3. We saw things like undefined. And so those numbers are coming back, but you still have a relatively small variety of numbers. That's it for the notes. Classwork time. I think we're good.